So while we are getting the last ones on board, I will just start by saying good afternoon and welcome to every one of you joining today's webinar with Sam Newman. And today it's about monolith decomposition patterns. And we really hope that the technology collaborates with us. We have strengthened our connection to the internet, so it should be fine. I really hope that a lot of you gain a lot of food for thought the next hour in the company with Sam. Just some practical stuff. Remember to mute your microphone, and since we are a lot attending today, also turn off your cameras. We are recording this webinar and we'll make it accessible, and I will share that with you in an email afterwards as well. Sam will do the talking and I will help him moderate the entire thing if necessary. And let's see here. There will be no break during this next hour because it's only an hour, so I think we can manage. Just a brief presentation of Sam, who is the speaker of today. He is an independent consultant and he is specializing in helping people shift software quite fast. He has also written a book, so I think you should all check that out. I think it's quite useful. And we have had a few events with Sam in the past, so many of you may already know him quite a bit. Other than that, I will actually just leave the word and the screen to Sam, who is ready and waiting. So Sam, the stage is yours. Sam?
Sam, you're muted.
Sam, you are muted. No, we cannot. We can't hear you.
How about now?
Yes.
There we go. So whatever you do, don't just turn sharing off and on in Teams, because that's what happened there. So just to give you a bit of a background, so Mary and I have been on for half an hour doing an AV check, making sure everything works. It's been absolutely fine. Of course, the moment we start recording, well, that happens. So even professionals theoretically can make mistakes. So thank you so much for all of you for coming along today. Just a reminder, if you've just joined late, please do keep your microphones muted. Any background noise can be quite loud for the rest of us. I would love to be doing this in person. I think I've done 2 or 3 evening talks now for Destination AARhus over the last couple of years, and I've always really enjoyed my time in the city. It can't be the case today, but I'm hoping this will make do until I can come visit again in person. As Maria touched on, my focus is on sort of helping people ship software more quickly. And I do that kind of through a number of different areas that I specialize in. I suppose I'm probably best known for microservices. I wrote a book called Building Microservices that came out in the beginning of 2015. I think I was just fortunate that I happened to write the first book on microservices. I'm in the process of working on a second edition of that book, and that will be available next year, probably around June, July next year is what we're aiming for at the moment. I also now run my own company. I do a lot of consulting work, training, advisory work. Nowadays, that's all being done online. Lots more information about that over my website. And my latest book, Monolith to Microservices, was actually published at the end of last year, and that's now available. What you're going to hear from today is just really a kind of a few little ideas from this book. So if you're interested in exploring the ideas behind this talk in a lot more detail, this is the book for you. If you follow that link, you're going to be able to find a lot of information about how you get access to it, how you can read it online, get your own paper copy, whatever else you might want to be able to do. Other couple of things, the recording's going to be made available, and as Maria said, she'll share that around. We'll also make the slides available for download after the talk as well. And if you do have questions for me, if you can hold those to the end, and I'll have time at the end to answer any questions you might have. So we're here to talk about kind of moving from a microservice architecture to a monolithic architecture. And, microservices are great, right? A lot of people like them nowadays. They've become very fashionable. But we like lots of the things that microservice gives us, and the property I often talk about the most is this property of independent deployability, right? The idea that I can make a change to a single microservice and roll out a new version of that microservice, releasing that functionality to the wider world, and that's great. But microservices are not without their challenges. And so actually, when I work with clients, typically I don't start with a microservice architecture. Most of the time, people have an existing system that they're looking to transform into a microservice architecture. We normally talk about moving to microservices from the monolith. Okay, so we think about the monolith in a very sort of strict way as being this big unchangeable thing. The reality is most monoliths, when you get down to it, can be changed by us. It's not easy to change. They're not easy to break apart. But sometimes there's a lot more we can do than we think we can. Now, when I talk about a monolith, I'm primarily talking about the monolith as a unit of deployment. And so we think about the classical view of the monolith being the single process monolith. All of the code associated with my application is bundled together in a single process. All of my data is in a single database. And this is a very, very simple example of a monolithic application. It's probably worth saying it is a distributed system. I'm talking to a database that's probably on a separate machine. I might be serving up content for a UI that's running on yet another machine, like as in somebody's browser. But it's a very simple deployment model and quite straightforward worldview. But if I want to make a one-line change of code, I'm still replacing and deploying the entire monolith. We have variations, of course, of this single process monolith. We have things like the modular monolith, whereby we've taken that single we've taken that single process and we've broken all of the code down into separate modules. Those modules can be worked on independently by different teams, but if I want to release a new version of that module, I still have to assemble them all together and deploy them. It's what we would call static linking. So your process that you're running that represents your monolith, and that consists of lots of these modules assembled together. Now, we most traditionally think of these modules, I wouldn't say traditionally, I would say in recent times, if you talk to people about using modules and linking modules into your program that you want to deploy, people immediately start thinking of reusing open source code, jar files, gems, NuGet packages, whatever it might be. And that's absolutely one example of how you could go about linking in with modules. But those modules could also represent code that you or your colleagues write. So this could be a way for you, say, having 5 separate teams owning different parts of the monolith, able to work in isolation to an extent from each other. You then assemble those modules together to release your applications. This does allow some degree of independent working, even though we still have kind of to deploy it as a unit. And so we still have to coordinate around any release activity. In my opinion, this is an underrated option, and not enough people, I think, really kind of look at in a rigorous fashion, thinking about modular decomposition within these larger code bases. I have a theory that if more people were better at creating modular monoliths, that many of those people would not then need to look at microservices. To an extent, having a microservice enforces a module boundary because it's very hard to change once you've made it a microservice. We can also take this sort of modular monolith approach to a sort of an extreme, which is something I've done in the past, where I will even keep the data for those modules separate. And that can be beneficial if I potentially might extract these modules as microservices later on. I can hear running water in the background, so if someone could maybe mute their microphone, that would be great. We have other types of monoliths so that we can consider things that we can't easily break apart ourselves. And this is where we blur the lines a little bit about whether or not a monolith is just a unit of deployment. We can think of something like a third-party monolith. These could be on-premise software. It could be a SaaS product that we make use of. We've got functionality and data inside that system, but we can't really change the underlying system itself. The best we might gain access to is getting access to the data underneath, or maybe intercepting API calls. Things like PeopleSoft and Salesforce and SAP. These are the kinds of complicated software that might fall under this sort of bill. But also, I've seen a lot of people build up, lots of functionality on top of content management systems, and then start to realize there's too much in the CMS. How do I start pulling this stuff apart? And maybe while I'm at it, reducing my horrendously high Adobe Experience Manager license costs. Probably the most difficult and complicated form of monolith to deal with is a monolith called the distributed monolith. And this is one where we have a distributed system. So we've got these individual services, but that the service boundaries are drawn in such a way that we always have to deploy the whole thing together. And often that can be the case because our sort of the changes in business functionality constantly cut across multiple layers of these architectures. So we often find ourselves having to change 5, 10 or 15 services together just to roll out a very simple change in the behavior of the system. Often in those situations where we don't have good cohesion of our business functionality, we find ourselves just kind of enshrining this idea that we're just going to always replace the whole system together. And that's more problematic. If you think about the ceremony of just deploying a single process monolithic system, it's not too bad. You've got maybe one moving part, maybe two if you've got to deal with database changes. But if I've got multiple services, all of which have to be deployed together as a unit, the amount of coordination required is much greater. The cost of deployment, the cost of change in these architectures tends to be quite high. The scope of deployment, much greater, lots more stuff that can go wrong, and a much higher requirement for release coordination. What I've tend to find is that distributed monoliths have all of the downsides of distributed systems like microservices do, but they also have many of the downsides of normal monolithic architectures, and they kind of end up being the worst of both worlds to an extent. I also do see this sort of distributed monolith emerge in organizations that overuse or maybe misuse the concept of the release train. So the release train is a useful concept in thinking about how we can increase the frequency of our deployments. So one of the things we're always striving for is to release software more frequently. If you release software more frequently, each release is smaller in scope. It's easier to verify that it hasn't changed or impacted or broken the system in a certain way. You get the functionality out to your users more quickly. If a problem does occur, it's much easier to work out what the problem was. And all the evidence has shown, from lots of research, that organizations which do faster and more frequent releases end up having lower defect rates as well. So the drive to release more frequently is great. One of the practices that can help get you to implementing things like continuous delivery is the use of something called the release train. The idea behind the release train is to say, well, we set a release cadence. We say every 4 weeks, we release all the software that's ready. And so the 4-week deadline comes up, everything that's ready gets deployed. The idea, though, with the release train is that you're supposed to, over time, increase how frequently the release train leaves. So you go from 4 weeks to 3, 3 weeks to 2, 2 weeks to 1, and eventually you get rid of the release train and replace it with continuous delivery, which is much more of a release on demand metaphor. Release on demand concept. But the problem is if you stick with a release train for too long, especially if you have a release train across your entire system, you almost codify this idea that everything gets released together. Every 4 weeks, all the services that have changed get released together. The way to think about a release train is like training wheels on a bike. It's there to help you ride the bike, but eventually you get rid of the training wheels because they start to hold you back. The same is true if you're looking to adopt continuous delivery. I've been quite down on things like SAFe in the past because, for many reasons, but one of the reasons I've been quite down on SAFe is the fact that it codified the release train as being the ultimate way of releasing and managing software. It made it aspirational when it's not. It's arguably a remedial technique. If you're in an organization that's making use of the release train concept, one of the things that I can urge you to do to avoid running the risk of becoming a distributed monolith is to at least apply the release train on a per service basis. Allow microservices to be deployed independently of each other. If within one team you want to adopt a release train concept, absolutely fine, go for it. But don't do that across all the services that you've got in your ecosystem. If you end up with a release train for too long, even if you start out with services that could be deployed independently, you'll find over time that that's no longer the case. Things just get bogged down and become overly coupled. So it's not just about thinking about our architecture that makes independent deployability happen. It's also thinking about our release processes. We want to avoid the distributed monolith because it's going to cause us challenges. Instead, we're thinking about continuous delivery, where we treat every single check-in as a release candidate. Every single thing we check in, we think could go into production. I have no problem with that. When you get good at doing that, you can release much, much more frequently. You can release whenever you want. You don't have to wait for a certain deadline to occur. And these are the things that make independent deployability a reality. I got interested in microservices because I was doing work to help organizations implement continuous delivery. And I realized it's often the architecture itself which was the main inhibitor in making that work. So that's talking about the monolithic system, the different styles of monolithic system, and different types of monolithic architectures will cause you more or less issues when we're looking at migrating them to alternative architectures, like moving to a microservice architecture. And there are obviously other factors involved, like the quality of the code, your familiarity with the code base and the tools and technology that were involved in building it. Quite often, people will also throw in the desire to modernize and change over to new technologies at the same time as re-architecting, which is always going to make your life a bit more difficult. So if you think about the monolith, right, we go, okay, let's imagine that we've decided we want to move to microservices. The next question really is, okay, well, where do I start this journey? What is it that I break apart here? Now, there are different ways of finding service boundaries, but the most common technique I tend to use is making use of domain-driven design to understand what my domain model is for the existing system. If you're interested in exploring domain-driven design in more detail, I'm still a big fan of Eric's original book, but if you want maybe a more condensed version, I'd strongly suggest taking a look at domain-driven design distilled. In domain-driven design, there's lots of great ideas in this space, for everything from just simple things like ubiquitous language. But a concept that's really useful for us in the context of building microservices is this thing called the bounded context. And this represents part of your domain that's like that can almost be treated as a separate unit. Quite often, bounded context map to parts of your organizational structure. And so you can say, well, okay, all this stuff here, this is the warehouse. And the warehouse handles our stock management. It handles shipping goods. I don't really need to know the detail of how the warehouse operates. I just need to know how much stock we've got in place and be able to know when an order's been sent. Other than that, I'm happy to delegate whatever they want to do inside. That's fine. And we think about that in software terms, that ends up making for a fantastic microservice boundary. But if we're going to take a domain-driven design approach to our microservice design, we'll normally be looking to identify these bounded contexts and use that to find what could be our service boundaries. So if I'm looking to decompose a microservice, say a monolithic architecture like that, going through some kind of domain modeling exercise is often my first start. And that will help me project onto that existing system the kind of microservices that I might want to extract. So in this situation here, we've identified a number of things that we kind of think make up for bounded context. We've got something around invoicing, something around order management, loyalty, being able to award points, notifications, the ability to send emails, contact customers and the like. A domain model will also help you understand how these logical domain concepts are related to each other. And this becomes a useful thing when starting to think about which microservice should I pick first. Because I might be tempted to look at notifications and say, well, look, that looks pretty self-contained. I can kind of understand how that would work. So maybe I should extract that as my first microservice. But then I look at all of those inbound calls and I suddenly realize if the concept of sending notifications to customers is so core to our system, it's likely going to be really integral to our existing monolithic code base as well. So it's going to be more difficult for me to extract that functionality into a microservice, at least initially. Because if I want to logically move that notifications functionality out to a microservice, all of those inbound links have got to be changed, have got to be updated. On the other hand, I look at something like invoicing and think, well, you know what, that could be a good candidate, right, to extract. I could extract that more easily. It seems like it's more self-contained. Now, obviously, you would back this sort of analysis up by looking at the code base as well and seeing what's actually going on in the code base, because your domain model may not have any relationship to how you've actually implemented the monolithic system, right? So there's a bit of a challenge there. Now, at this point, we could talk about just arbitrarily extracting microservices, and that's fine. But we kind of have to deal with a fundamental truth, and that is that the monolith is not the enemy. It is incredibly rare that when I work with organizations that are moving to microservices, the problem is they don't want the monolith anymore. That's not ever really the answer. What it tends to be is that their existing system architecture, their existing monolithic service architecture, somehow places a limit on what that organization is able to do. It constrains a change they want to make. Maybe people feel that developing in the monolith is slowing them down, or that they can't scale the application in a suitable fashion. So you're not ever trying to get rid of the monolith, or very, very rarely are you trying to get rid of the monolith. Most of the time, you're looking to change the monolith enough to achieve some end goal. And so, you know, that's what we have in the back of our mind. So microservices should be a means to an end. I would also say at this point that microservices should not be the default approach. I mean, microservice architectures bring with them a whole host of baggage, a host of challenges, problems, issues. You know, you're going to be solving problems you'd never wanted to ever have to solve by adopting a microservice architecture. And so you've got to be really sure that all this work is justified. So what you need to do is think about what problems is it that you're trying to solve. So you might say, okay, well, I want to improve. I want to basically scale up my application to handle the increased customer load that we're going to expect. Okay, great. That's a fine goal. Right now, we can handle 100,000 customers. We want to be able to handle 1 million customers. Fine. I would always start looking for. So if you focus on the outcome, our system can handle 1 million customers. Then you should be honest and say, well, what are the ways we could achieve that? And sort of do a brainstorm, list them out. I could do that by microservices. Maybe you could. How else could you do that? We could get some more hardware. We could have lots of copies of our monolith. Guess what? If you can just spin up more copies of your monolith and that helps solve your scaling problems, that's likely to be much faster and cheaper and more straightforward than moving to a microservice architecture. So when I work with teams, you know, I will always push back if they want to go microservices. I'll say, well, what is it you're trying to achieve? Why are you trying to do it? Have we tried the easier stuff first? If you don't have a sense of the problems you're trying to solve, it's going to be very difficult for you to make meaningful decisions about which microservice should you start with or how many of them should you have. The sort of metaphor I've been using for a while now in terms of thinking about adoption of microservices is thinking about it less like an on or an off switch, more like you're turning the dial. You're creating a microservice, you're deploying it, you're getting it to be used by your end customers, your end users, seeing if that solves your problem, seeing if it solves the customers, the users' problems. And if it does, great. And if it doesn't, well, you can change your mind. This is about gradually turning up that dial, gradually adding 1 or 2 services, learning from that experience, assessing whether or not it's made your life better or solved the problems you're trying to solve. And then based on that, you can decide, okay, should I ramp that up a bit more? Or maybe I should back that off. Not every organization needs tens of thousands of microservices. Most do not. You might be happy with 4. Don't go around comparing how many microservices you've got with other people, except as bragging rights. Your customers do not care if you're using microservices. Your boss probably doesn't care if you're using microservices. They might care about the things that microservices could give you or could help you do, but there may be other ways to more effectively achieve those end goals. I was doing a class earlier for some of other people in Destination AARhus, and I said to them, you know, you don't win by doing microservices. I win by doing if you do microservices, because I sell books on this topic, right? So just separate, microservices are an activity. You want to focus on the outcome and then work out the right activity to achieve that outcome. Because there are some nasty things lurking for us in the world of microservices. You're not going to appreciate the horror, pain, and suffering of a microservice architecture until you're in production. This is where the vast bulk of these issues are going to kick you in the behind. And you can theorize about this all you want, but until you're doing it, you're not really experiencing it. And so it's for this reason I really try and focus this idea of trying microservices by create one microservice. Identify a good candidate as your first step. Extract that functionality, deploy it into a production environment, integrate it with the monolith in whatever way you need, get it actually being used by end users, assess the impact, and based on that, decide where you go from there. We don't want to do some big rewrite of a system into a microservices and then try and deploy all of it at once. It's going to cause so many challenges. As Martin Fowler says, if you want to do a big bang rewrite, the only thing you're certain of is a big bang. And look, don't get me wrong, I love an explosion. Do I really want an explosion at my place of work? So what we want here is a way of taking our monolithic system based on what we're trying to achieve, working out which microservice to extract that microservice out, get it into production, see how it works, assess if it's working well, and then go, great, fantastic. So if we're going to make this an incremental decomposition, we also are going to need patterns that allow for some kind of incremental change. And this is where I typically hear I'm talking about refactoring patterns. Many of you might think of refactoring in the context of something like where I'm renaming a method or extracting a class or something like that, and they are refactorings. A refactoring is something which changes the structure of code without changing the behavior. And normally with microservice architectures, that's what we're trying to do. We're trying to change the architecture, but still maintain the same behavior so that we've got a baseline to make sure that our changes have worked appropriately. So all the things I'm going to share with you now are refactoring patterns, things that allow us to make a change to the structure of our architecture, but still verify that our systems are behaving correctly. And I'm also going to show you patterns which you can, each of them by themselves is a small step, but that small step can be broken down into lots of smaller steps. This allows you to do this refactoring while you're also still shipping features as well. The first pattern we'll look up in this space is looking at how we deal with sort of pulling application code apart. And this is a useful pattern called the strangler fig application pattern. The idea here is it's sort of inspired by this type of plant called the strangler fig, which wraps itself around existing trees. Without these existing gum trees, it'd be very difficult for the fig tree to survive or to take root. So it wraps itself around. Over time, it becomes bigger and bigger and stronger and stronger. The fig tree can then stand by itself, and then it no longer needs the underlying gum tree. It's normally a gum tree. So this is in Australia. And so the idea here with our system migration is the same. We're going to take an existing system and we're going to wrap that sort of existing system with our new system. So overnight, we're not going to have a replacement for everything. So we just replace one small piece of functionality. We sort of wrap that new piece of functionality around the old system. When a call comes in to use that new functionality, it is intercepted and diverted to our new implementation, which in this particular case would be a microservice. And over time, you can add more and more functionality, but that you're kind of still supported by the monolith in this world because the bulk of the functionality lives in the monolith and you're just gradually sort of moving it away. So it's all I hope it's quite straightforward. I'll take you some example in a minute. So basically we're intercepting calls on the perimeter of the old system and diverting that to our new, where the new functionality is, which is our microservices. When we talk about moving of functionality, by the way, moving it from a monolithic system to a microservice system, we might be talking about things like copy and paste, but it's often more likely to be a total or a partial rewrite of a piece of functionality. So maybe you can find the code you want, you can copy it and paste it into a new service, but maybe you're actually just going to rewrite that little bit of functionality. It's your choice really, but it's a logical movement. And often there's a lot of value in leaving the functionality in the monolithic system as well, because that gives you good options for fallbacks or doing comparison runs using things like parallel runs. So a good candidate in our example here for a strangler pattern would probably be an invoicing or the order management here. These are things that are going to be towards the top of the call stack for our monolithic system. We're going to have calls coming into our monolith saying pay invoice, or create new order. And so we can intercept those calls. It's a very simple example of this being used for a HTTP-based system. So here I'm sort of intercepting calls underneath the user interface. So this would only be solving the application tier decomposition. We still want to look at the UI and the data as well, but I'll leave that as a conversation for another time. We will talk about data decomposition a bit later on. So I put a proxy in place between my monolith and the upstream calls. I intercept the calls that come in. I say, oh, okay, well, the call coming in, is it something for a new microservice? No, okay, well, in which case I'm just going to pass you on to the monolithic system, or if it is, I'm going to pass you off to a new microservice. Now, as part of phasing the deployment of this and phasing the rollout, I would drop this proxy in place straight away. And at that point, all the proxy is doing is allowing the calls to continue to the monolith. This gives me a place at which I can be checking the latency of these operations and just making sure it works. Right? It's not doing anything. It shouldn't have cause any problems. But I can assess the impact of adding an additional network hop here. Then I can deploy my new microservice. I can make sure it's working correctly. And then once I'm happy my new microservice is working correctly, I can configure the proxy to divert calls to my new microservice. Now, if I have an issue with that microservice and maybe the functionality stops behaving correctly or whatever, or it just has a bug, it falls over, it crashes, whatever else, if I haven't done enough preparation and enough testing, that functionality still lives in the old monolithic system. So I can just divert those calls. So HTTP works really well with strangler fig application patterns, largely because the HTTP protocol itself has some really good support for handling transparent redirection of calls. But I have actually used the strangler fig pattern for replacing parts of user interfaces before. I spoke to a company last year called HomeGate, who actually used this pattern for migrating a sort of FTP-based system. So they were actually intercepting FTP calls. I've also done this with messaging systems as well. Any system where you can basically intercept a call and divert a call, if you've got that mechanism available to you, those are pretty much the building blocks you need to implement a strangler fig application pattern. Now, I haven't talked about data, so we'll come back and talk about data a bit later on. The next pattern we're going to look at is, and there's a lot more detail for these patterns, a load more in the book if you want to go deeper into all this stuff. The next pattern we're going to look at is for solving something a bit more difficult. Like, well, what happens if I want to, say, extract the ability to send notifications or to award points to my customers, right? So I've got loyalty points here. So when someone pays for an order, we give them points to say, thank you so much for buying stuff from us. But we don't have a call that comes into the monolith that says, give Sam 500 points. The call that comes in says, place an order. As a side effect of placing the order, we award those points. So I can't intercept the point awarding stuff at the perimeter of my system. It's inside the monolithic system. So I'm going to use a different technique to replace that loyalty or the notifications functionality with our new microservice implementation. And this is where we use another pre-existing pattern called branch by abstraction. And this is more historically used in the context of people who practice trunk-based development, but it's really useful in this context as well. So the way branch by abstraction works is that you create an abstraction point inside your code where you can basically sort of hide ongoing development. That's one way of looking at it. Another way of looking at it is like it gives you a point behind which you can hide two different implementations of the same functionality, and you can decide which one you're actually going to use. So what we're going to do is we're going to say, well, look, our current implementation of notifications is inside the monolith, but we also want to work on the new implementation that's going to call out to our microservice. We want to make the fact that we're doing that work kind of invisible to the rest of our monolithic system. And we also want to create an abstraction which can be cleanly swapped in or out so that the rest of the monolith doesn't actually have to care about whether or not that's being fulfilled by an external service call or a local implementation call. So that's kind of the idea. So to walk you through how that pattern works, we start off with our existing system, our existing monolithic application. And the first thing we're going to need to do is to create the abstraction point. So in the case of our notifications functionality, we're going to be looking for all the notifications related code and looking to group that together in its own kind of abstraction point. So in an object-oriented system, I might create an interface, a notifications interface, and a class which implements that interface. I would then get my, say, order code and invoicing code and say, well, rather than calling these SMTP libraries or the Twilio APIs directly yourself, instead, I just want you to talk to this notification interface, and that's what you're going to deal with from now on. So we're sort of hiding the existing implementation behind that abstraction point. Now that is just good old-fashioned refactoring. We're just creating an abstraction. I'm sure you've done this before, and even if you did nothing else, you probably end up making the code base a bit nicer, a bit easier to deal with, right? It's maybe more testable at this point because you can plug different implementations in for testing purposes. Next, we're going to start working on our brand new service implementation. This is going to implement notifications by making service calls. So when someone now calls the notifications interface, they don't need to worry about which one we're actually using at runtime, but we have the ability to change them. Because we're not actually yet using our new implementation, it's not yet wired in, we can safely check this into mainline, have it committed, integrated with all the other code. We don't have to do this work on the source code branch. And that's part of the reason why people often will use branch by abstraction to avoid the need for feature branching. I can do all of this in sort of the main trunk. And this pattern is used a lot by people that do trunk-based development. So if you're looking to maybe decrease the impact that long-term feature branches have on you, you might want to look at this pattern for general software development anyway. So our service calling implementation is going to kind of delegate those calls out to the notification service. So it's kind of, I've got a bit of client code for my microservice running inside the monolith that implements that notifications interface. Pretty straightforward stuff at this point. Once we're happy that the new implementation is working, all we need to do is change the implementation of that notifications in abstraction. And that could be done with a feature flag, could be a runtime or a deploy time feature flag, and say, well, actually, right, now use this one instead. The rest of your system should not care, and things keep working as appropriate. Once all that's done and you're happy it's working, if you wanted to, you could then go and clean up the monolith. Because you've done the work to refactor all of your notifications related code, you've put it behind a nice abstraction point, you know it lives in this class, for example, well, then you could just go and delete that code and you've made the monolith smaller. And who doesn't like doing that? The process of creating abstractions as we go, you know, these sorts of abstractions and doing so in a safe manner inside a code base, which maybe not has been maintained well, or you might now consider to be a bit out of date. I can thoroughly recommend this book, Working Effectively with Legacy Code by Michael Feathers. Loads of great examples about the things that you can do to make those kinds of refactorings work. This book does not talk about microservices. It just talks about the effort of refactoring your code to make it sort of more modular in nature, which helps us because then we get these abstraction points that we can switch between. Because we've got both the old implementation and the new implementation running side by side inside the monolith, we can also do kind of some things that look kind of funky and a bit odd, but can be really useful. One pattern that can be incredibly useful is a pattern called the parallel run. With a parallel run, you basically take two implementations of the same functionality and you execute both implementations on every call. The idea here is that you actually get a proper comparison in the live running system. Now, obviously, you have to be a bit careful about where you make use of this parallel run pattern. You wouldn't necessarily want to send two emails to every customer when you would normally send them one, but you could still do that with the notifications interface, but have your notifications service talking to, say, a dummy SMTP endpoint. This process of doing parallel runs has been around in computing for decades. Typically, you do it for entire application stacks, you know, running these two systems side by side, but it works just as equally inside a code base like this, where I can execute the things twice. I mean, that's if I've got an interface, creating an interface that what it's called actually just calls both two underlying delegates, not hard to do that. It's a very simple piece of code to write. The kind of effort really is in sort of dealing with the dirty reads in that situation and making sure you don't get unforeseen side effects like sending two emails when you only meant to send one. GitHub actually makes use of this approach quite a lot. They've got a library called GitHub Scientist that they use for when they're refactoring their critical code paths. And so it's like a nice little Ruby abstraction for helping you sort of coexist those two implementations and do scoring around them to make sure that the new one is behaving correctly. And GitHub Scientist has now been ported to a bunch of different languages if you're interested in that. One of the things that's kind of interesting as well here is if we can kind of coexist both our new and our old implementations, we can do things like parallel runs. We can also do things like sort of looking at things like canary rollouts. In fact, a lot of power comes from this idea of separating the act of deployment from the act of release. And this crops up a lot. And for a lot of us, we've conflated these two ideas in our head. When I deploy, I've released my software. Well, it doesn't have to be like that. I can deploy it into production, spend as much time as I want verifying it, running smoke tests, whatever else I want, and then I can release it to my users via a bunch of different mechanisms, some of which I've already shown you today. But that opens up different ways of thinking about how we release our software. James Governor, who's the co-founder of RedMonk, has sort of coined this term progressive delivery, which basically articulates a whole kind of umbrella term for lots of different release techniques that are shifting how people think about delivering digital services. I don't have to do one big release. I can do canary rollouts. I can compare which versions of my software work best and pick one with A/B testing. With parallel runs, I can run the whole two systems side by side, making sure the new one works. I've got blue-green deployments, which is kind of quite a basic form of this. And even things like dark launching, which gets really funky. It's where you sort of send software live but don't tell people. Which seems a bit of a niche idea, but that has, again, surprisingly useful. So this is a really interesting article by James Governor if you want to read more on that. Now, so far, those eagle-eyed people amongst you may realize that I have totally sidestepped the tricky issue of the database. And that's because extracting, decomposing databases is difficult. Jim, hopefully you're aware, when we talk about microservice architectures, one of the key things we talk about is the idea of independent deployability. We want to be able to make a change to microservice without changing anything else. For that to work, we need to have clear, well-defined service interfaces that we can maintain backwards compatibility for. If I can't maintain backwards compatibility when I make a microservice change, I'm going to break my consumers. And at that point, maintaining independent deployability becomes difficult. One of the ways we achieve that is by sort of trying to hide data inside a service boundary. We don't want everyone to use the same database. So that gets kind of interesting though when we start thinking about these phased migrations. I've extracted my invoicing microservice from that monolithic system. That invoicing microservice needs some data. So what's it going to do? Well, we don't really want to just directly access the data because that causes all these coupling problems. When we look at microservice architectures, so much of what we're doing is saying, look, don't share databases, right? If a microservice has some data that it needs to store in a database, treat it like an internal implementation concern. If an external microservice wants to access information that a microservice has, it goes and asks for a well-defined service interface. Think about your microservice like it's a black box. I go to a well-defined service interface, could be a REST-based API, could be a gRPC endpoint, I could be subscribing to your events and your Kafka topic. They become your explicit representation of what your consumers expect. And it's much easier for me as a developer to know what I can change safely. People reach directly into my database, I've lost that ability. So we're trying to practice this idea of what's called information hiding that information away. So really, we don't want to do this. So we don't really long-term want to be accessing the same database. So we've got to think, okay, well, if I can't access a database directly, what else should I be doing? The next question then is, what is the nature of the data you've got? If the data in this situation the invoicing service wants is, say, order-related data, it should go to the monolith to fetch the order-related data. Orders are still managed by the monolithic system. So expose the information the invoicing service needs via some kind of service interface. In this example here, a REST-based API. So the order data is owned by the monolith. I ask the order data to expose that functionality to me. I can have a schema for the interaction. That means I've just got to maintain the compatibility of that. Whenever I make the changes in the monolith, I can make sure I don't break the invoicing service because I know what the invoicing service needs. And also, of course, in this stage, you start helping you kind of charting a path towards what a new microservice might be. Well, if you do some things like this, if you expose service interfaces from your monolith, don't call them the monolith API, right? If this is for accessing order information, call it the order API. The invoicing microservice just thinks it's talking to the order API. It doesn't realize the order API actually is exposed by the monolithic applications and need to care about that. But that will start helping you understand, okay, well, maybe there's another microservice that I want to create that's going to implement that API more cleanly. So you can kind of start to see like a microservice struggling and wanting to emerge and fight its way out from that monolithic system. And so maybe this will help you identify the next step you might want to make. Of course, we've also got to think about the reverse situation. What if the data you want is actually your data? In that situation, you're just going to have to go grab the data from the monolithic architecture. That's your data, your invoicing data. We're going to have to rip that out of the monolithic systems database, move it over to your database. And then if the monolith wants to access that information, you need to get them to come to you in some way, shape, or form. Just to give you an example of some of the challenges this creates, I'm going to take you fairly quickly through one of the nastiest examples you see. And this is an example of how we handle things like join relationships when we're breaking these things apart. So I've got an application right now that is handling the e-commerce sales for an online music shop that sells compact discs. So one of the things that we need to do is that we need to generate a list of the top 10 bestsellers in the last 7 days. I've got, what I'm looking at is potentially extracting out 2 new microservices, one for the catalog and one for all of our finance-related activities. The finance microservice, as the current monolithic architecture does, implements kind of records, it stores records associated with all our financial transactions. So if I want to know if I sold a record in a given day, that's going to be in this ledger table that's down here in the bottom right. But as we see from that ledger table, we don't really get much useful information about the nature of the record we've sold because that information is actually over in the line items table. So if I want to know if the item I sold with the ID of 123, what it is, I'm going to have to go look up that record in the line items table. So this is just a foreign key relationship. So if I wanted to generate this top 10 list, that's just going to be a case of doing some kind of join query. So I'm going to select details from the ledger, get that top 10 list of IDs, and then I'm going to join those IDs out to the line items table so I get the name. Pretty straightforward. Obviously, though, if catalog and finance are going to become separate microservices, I'm going to have to break that join relationship because the database is going to be different. What you would do is look to move that join relationship from the data tier up into application tier or the services tier. So the process would now work like this. I'd go, what are the best top 10 bestsellers? Well, okay, I'm going to go fetch the top 10 IDs. I've only got the IDs now. I need the names. So then I make a service call over to catalog, say, can I have the record names, please? Here's the IDs. The catalog service goes and fetches the data from the database and sends me back those IDs, and then I can generate that top 10 list. Now, of course, all those red lines there represent, network calls that are going to add latency to this operation, and that might be something that you start to worry about. There are ways around that. We'll come back to that later. We've also got to consider what happens in these situations in regards to things like our foreign key relationships. This relationship, for these foreign key relationships in a relational database, do three key things for us. They enforce referential integrity. They make it sure that if I try and delete a line items record, it's not going to break another part of my system. They also make relationships explicit. So I can see that this is related to this other thing. And they also aid join performance. So when you tell a relational database that these two things are related, the underlying relational database does some optimizations to make your join queries much faster as a result. So some of these things are easier to solve than others. Making relationships explicit can be as simple as just coming up with some kind of pseudo URI scheme. This is a great article by Phil Calzado outlining how he saw this done at SoundCloud. So when I'm, in one microservice, I might have a reference to something. It might say SoundCloud : tracks : 123, and that says to me, okay, well, to get to what this reference points to, I know I'm going to the tracks microservice, and I need the ID of 123 to pull back the item of what I want. And then I could store that URI in my actual database, right? So I know when I see that number, it's not like a vague number or what's an arbitrary number. I don't know what that means. If it's actually using something like a pseudo URI scheme, I know I've got more information and metadata now about what that ID relates to. It becomes easy for me to say, oh, that's actually a pointer to an entity that's actually managed in another microservice. So I'm going to have to go and do a service lookup to fetch what that entity looks like. And in this example here, I haven't used that. So I've just kept 123 in the ledger. So if I was looking at that ledger in isolation, I wouldn't necessarily know what that 123 means. But if I'd made out a pseudo URI, it might be much more obvious. And I quite like that characteristic. We obviously don't have referential integrity either, right? There's nothing to stop me deleting row 123 from that database. And in which case it's like, oh no, what am I going to do? Now, there are some quick fixes for this, right? One of the easiest things to do is effectively implement something like a soft delete. So rather than actually removing the row and causing issues of referential integrity, I might just add a status column. And when the item is deleted, I just say it's deleted. It's still actually in the database, but it's just maybe not available for sale anymore. But the ledger is still able to reference that and pull back information about that record. So that's one really easy, quick fix for this problem. Another idea here may be to copy the data. So when I made the sale, I could actually write down the name of the album, the name of the record. This kind of is useful because now I don't even need to look up the name. But when I copy data like this, the one thing I have to watch for is what happens if the source data changes. What if we typoed the field and actually it was the Best of Death Polka Volume 5? We update that in the catalog system. How do I update that in the ledger? Now, a lot of this depends on why you're copying data. If you're copying data as an historic record, which is what you might be doing with a ledger, you might want to keep it as the old name because that's the name of the thing as it was when you sold it. And you want that in the ledger, so you wouldn't want it to update. In another situation, though, you may want that data to update, in which case you need some mechanism to update it. If you're storing a copy of data that you're doing so to avoid making calls, and you want that copy of the data to update when that data is no longer, when it changes, you've got a cache, right? And then all the other stuff associated with caching comes into play. But something like a financial ledger, I may actually want a record of what it was at that point in time, because you should treat a financial ledger as a completely immutable append-only concept, right? You don't want to go around removing items or rewriting entries in a ledger, because that's how you go to prison. Another people might say, well, actually, I'm going to go and check before I delete, right? This does not work very well. So in this situation here, I'm going to remove item 123 from the catalog service. The catalog service goes and checks the invoice service, says, are you using item 123? I've then got to wait for the invoice service to come back and say, no, I'm not referencing that item. Then we can go and do the deletion. Now, this, even in this simplified form, has problems. How does the catalog service know which microservices to ask? Effectively, any microservice that can have a dependency on a catalog item in the catalog microservice now means the catalog now needs to know about that and be able to go and ask them, are you using this ID? This beats having now some sort of common protocol across all potential microservices that might access you, or you're hard coding this stuff, in which case whenever you add a new microservice that might reference something in the catalog, you've also got to update the catalog to know that's a microservice it's got to go and ask about deletions, which just seems unmanageable. We end up effectively with this sort of explicit circular dependency. And even if we did all that work, it's not actually guaranteed to work unless we do some more things on top. We end up actually, if we wanted to guarantee that this could work for some value of the words guarantee, we would have to lock data. I would have to go to the catalog microservice and say, please delete item 123. The catalog microservice will go to the finance service and say, are you using row 123? The finance service takes a look at its database, goes, no, I'm not using that. The catalog service goes, great, I'm going to delete. And in that fraction of a second, a fraction of a microsecond or a millisecond before it does that deletion, we sell an item. We sell an item of 123, and the finance service goes, right, sure, we sold that item, and I've updated that in my database. Now I've got a reference on this item. And we do that just after we've been asked about it, but before the deletion occurs. So now we've deleted the item from the catalog, but we do now have a reference in the finance service. Now the window for this happening might be small, but it does exist, and therefore it's not a guaranteed behavior. The way you'd solve this would be to lock. So when I go to the finance microservice and say, oh, I'm using row 123, and the finance service goes, oh, of course I'm not. The catalog then goes, okay, great. Please place a lock inside your system so that you don't put a reference on row one on an item with an ID of 123 until I come back and tell you otherwise. So I say lock, don't create that record, don't create any records with this reference. I go and do my deletion, then I go back and tell it to remove that lock. And look, I don't have to tell you about all the sorts of issues that can occur when you're dealing with distributed locks like that. That's why a system like this is not something I would recommend anyone build. And this is also part of the reason when you start looking into this stuff is also why things like two-phase commits aren't a great idea in distributed system, because they're under the hood of, this is basically a two-phase commit, albeit with, you know, a different clothes on. So that's not great, right? But so typically in these situations, I would be looking at things like soft deletes or copying the data. If, you know, from a point of view of, for referential integrity point of view, both of those things can help. Or else just being more robust. If the number of times when we're going to delete an item in the catalog are pretty rare. If the finance service tries to look up a record that isn't there, don't explode, just go, information not available. Maybe that's good enough. There's all kinds of other stuff we can talk about in this area, but one last thing I wanted to touch on was sort of how we make it a bit faster. So when we've moved this drill up to the services tier, one of the things that we've really going to impact is the latency of the operation. And one of the easiest ways of solving this is caching. Caching, of course, is never just easy. It seems easy at first glance, but it causes other issues, not least of which is, well, where should I cache here? If I'm thinking about this situation, I've got multiple places where I could cache this information. I could cache this on the client side. Now, so the finance, somewhere inside the finance service, I hold onto that cache. And the great things about that is I avoid having to make that network call. So that's going to make this operation much faster. And I could potentially operate if the catalog was unavailable. If I had a full cache, that could work. So even if the catalog service is offline, I could still operate in that situation. The downsides is if I've got loads of clients and they're all caching, that's more memory probably that's being used to hold on to copies of the catalog information. And I'm more likely to see inconsistency in terms of what data is in that cache. If I've got 5 instances of the finance service and each instance of the finance service has its own cache of the catalog information. Depending on which instance of the finance service I look at, I might potentially see a different copy of that data. Even if I share a client cache amongst all instances of the finance service, there may be other microservices out there that have their own caches. So you can see windows of inconsistency in these situations. So the other thing here is that invalidating cache regions is more difficult in this situation. There are things you can do. You can use events to invalidate regions. A lot of people just use things like spice headers and TTL-based systems. Using HTTP, you can do things like conditional gets. And there's some, but they're not as sophisticated as things we could do if we cached elsewhere. And a lot of the invalidation mechanisms that you can do on client-side cachings can often lead to longer windows where you're seeing potentially inconsistent data. If you're building a system that already uses events, then using events to propagate these changes can also work really effectively. But again, you don't necessarily want to have to implement an event-driven architecture just to do invalidation of caches. So that could bring in some more complexity into your system if that's an approach you're looking at. We can also cache on the server side, right? The benefits here is invalidation is much easier. When I call the catalog service to change the catalog entries, at the same time I can invalidate any server-side caches sort of in line. So my invalidation is much quicker. Because we're going to have smaller, but probably because we've got more clients and servers in most situations, we're able to be much more efficient in caching as well. Downsides, obviously, the call still needs to be made from the client to the server. So if the bottleneck in your, and this is kind of where you would cache would depend on what problems you're worried about, right? So if the bottleneck in your latency, if you think the biggest bottleneck in terms of your end-to-end latency is finance having to call catalog in the first place, then just caching the server side isn't necessarily going to make things much better. It might avoid catalog having to talk to its own database, for example. But if that's all, if that only saves you 5 or 10% of the overall latency of the operation, it may not actually gain you much. We also have a third place we can cache, which is actually the request cache. So we could cache at the point where we say, give me the top 10 bestsellers. We could cache the results of that query. And that is going to be super efficient, right? So if we only need to calculate and update that once a week, that might be fine. Wouldn't be as effective if we're trying to update that top 10 on a rolling, minute by minute basis. But in general, that's going to be the most efficient mechanism here and would like to have the biggest impact in improving the performance of the system. That said, it is very, very targeted cache as well. It's a highly specific cache. Caching the request cache is unlikely to yield any benefits to other types of activity making use of the ledger or the catalog service. So it's not always the right way forward. So I've taken you through a real kind of whistle-stop tour on all sorts of aspects of microservice decomposition. We've looked at some application decomposition patterns, strangler fig application, branch by abstraction pattern. We've then taken a look at sort of data decomposition as well, how we pull the databases apart. If there's a few things I want you to take away from this. Firstly, if you want to go deeper in looking and exploring any of these topics, I'm happy to answer some questions now, but also there is a book available to you. Go read the book. There's information on my website about how you can access this book. If you don't want to pay for the book, you can go to O'Reilly Online Learning. It's like an online service that O'Reilly offer. You can sign up for a free 30-day trial and read the book without paying any money. Although, it would be nice if you bought a copy if you think this content is worthwhile. All that information you can find over at my website, along with other information about the kinds of work I do. I've also got recordings of virtual talks on there over the last 10 years. So there's going to be more than enough talks from me that you can watch there if you would like to. I have got a little bit of time now, though. I think so. I would like to maybe throw things open for a few questions. I think, given the number of attendees that we've got, I think probably the system may work the best is if people put their hand up, and I'll kind of say, yep, okay, what's your question? Or else, if you would rather ask a question via chat, you can just put the question in the chat window. So yeah, without further ado, has anyone got any questions for me? Okay. So I think we had a question. Oh, goodness me. Right. I don't seem to be able to see who's raised their hands. This is fantastic.
So for now, we have one from Henrik Amsing.
Yeah, hi, can you hear me?
Yep,
Yes.
go ahead.
Yeah, Sam, a great, inspiring session. Thank you very much. And also, I like your warning around just don't think microservices is, the end solution to everything. And there's a reason why Monolith are there and why they perform. I'm thinking if you sort of look forward into time, the new powerful public cloud providers seems to be building so many services now around their core offerings that a skillful software engineer nearly looks better if he can just compose over these vast amount of pre-prescribed services rather than writing the microservice from bottom up. Where do you think we'll end up, and where will this be sort of a combination of some microservices that are very unique to your business you write yourself, and then a lot of off-the-shelf services you compose? Or how do you see it?
I don't see there being a marketplace of loads of different microservices that you're going to drop in. I think what we're more likely going to see is sort of vendor software which plays nicer in a microservice environment. So, I mean, we've already seen a trend towards software which is headless. So if you think about a lot of the content management systems now, it used to be you'd get this huge monolithic software which you couldn't really integrate easily in your systems. Adobe Experience Manager I mentioned earlier is far from the worst candidate in this situation, but it's not as bad as it could be. But you are starting to see like a whole crop of content management systems, for example, which are what they call headless. So the idea being is I'm going to give you the really important aspects of a content management system, which is content editing and authoring and workflow, but I'm going to let you create your own presentation layer with that information. So I think that is something we're already seeing. And I don't think that's necessarily Microservice specific. I think that's vendors realizing people don't want to come to me and get everything from one source. They want a way to mix and match products from different people. And that's been really good, seeing more people understand that. There's actually this thing called the Mac Alliance, which has started up, which is trying to get like vendors to sort of share a kind of set of practices about how they create software that plays more nicely in a microservice environment. And certainly, a large amount of my career was just gluing other people's software together. It's quite depressing. It's like, I've got this thing and they don't want to talk. They've got to talk to each other. They don't want to talk to each other. And that's starting to get a little bit better. So I don't think, I think for that's what I'm hoping for in terms of bringing things in from the outside world. The other way I see microservices helping in terms of the way software is developed is in situations where you might want to make use of external parties to develop software on your behalf. So I don't know if you've read the book Accelerate by Gene Kim, Jez Humble, and Nicole Forsgren. That's basically a collection of all of the observations of the state of DevOps reports that have been going back for many years. And they've looked into things like outsourcing. And they found when an organization outsources the entire ownership of some part of a product, it's much more effective than just outsourcing an individual function. So in other words, you don't tend to see great outcomes. So high performing teams rarely will just say, I'm going to outsource a bit of my testing, a bit of my development. Instead, high performing IT teams see much better value by saying, I've got this thing that needs to be built. Can you build it for me? You go build it and run it, and I'll integrate with it. So that's actually a really nice way of working with external partners to design something that's specific for you, but keeping that behind a nice boundary. So I think those things and those trends, I'm quite hopeful of. And that's where I see things kind of going in the near term. But I hope that answers your question.
Yeah, it does. Thank you very much.
You're welcome, Henrik. Okay, my Teams has now decided to let me see the hands. It was not earlier letting me see the hands. It took about 5 minutes for the screen to refresh. So I just want to see if anyone else got any other questions for me. Please just put your hand up, and now that I can see the hands, I will ask you to state your piece. I'm also going to take a quick. I've also got the chat window open, so if you'd rather ask a question in that chat window, I'm happy to do that as well. So let me see if I can open the chat window. Right. Okay. No, not so far. Okay, well, it may be that I've just talked you all into submission and that you're just in violent agreement now. about all these ideas, which I'm fine by. That's absolutely okay by me. But if you do think of any questions after the fact, so I'm very easy to find on the internet. You can get my contact details over at samnewman.io and ask questions there. And you can also ask me things over Twitter. And I like answering questions over Twitter because everyone gets the benefit of seeing the answer of that. Mary, do you have any parting thoughts?
No, just that we will make sure to share the link for this recorded talk and a small evaluation and material. And just a great thanks for yet another great talk by you, Sam. And it has been an absolute pleasure.
You're welcome. I'll make sure I get those slides out to you just in a minute, Maria, so you'll have those to email to everybody as well.
Okay. So thanks to everyone joining.
Thanks, everybody.
Thank you, Sam.
Speak
Thank
to you
you very
soon.
much. Bye.
Bye-bye.